Shannon.
Right.
Hi, listener. Welcome to a new YouTube video. Remember to like, subscribe, and turn on post notifications.
Right. Okay. So this one here, it's just cosine rule.
Oh, I couldn't do it.
They tell you the cos A there is 3/4. So and you've got to find the length BC. So it's just cosine rule. So should we leave that one?
What's the answer?
You can plug it up.
Oh, of course it's not calculated, isn't it? So it's probably worth me. Right. Okay. So here we go. So we know the if we call this x, if you like, it's going to be x squared equals 12 squared and 10 squared. Doesn't matter which order we put them in. Minus 2 times 12 times 10 times cos of A. We know cos of A is 3/4, so it just comes down to a simple working everything out, not making the real stupid error of what's that? 240 times cos A, which is 3/4. I need to finish my line of thought there. Not making the stupid error of kind of doing it too early. But yeah, anyway. I think it's quite straightforward this now, isn't it? Because you do 240 times 3/4, which is 180. So you get x squared is 244 minus 180. Oh, it's 8. Because x squared is 64, so x is 8. Wow. That's not hard, he says. So write that. We could all have done that, couldn't we?
Yeah.
Sure.
Yes.
Yes, Morris, no.
You're the only one who said 2 now. Everybody else has said 1.
Wow.
We're being singled out.
Excited.
Yep, you are being singled out there. Right.
The only one with the work ethic to show up.
Yes. What have we got next? That is
That's just
a
normal maths.
quadratic inequality. Normal maths.
Is it quadruple? Is it?
Yeah.
Wait.
No, it's not.
How?
No, it's not.
Yeah.
It's doing well.
For a while.
What's that doing? Yeah, that's not what I wanted to do. Now what do I do? Yeah, I'll do it down there. So this is 7x, and this is 8x minus 24. And the area of the pattern is less than 51. There's going to be a little bit of a sneaky thing here. So add those together. I know, and it's got to be less than 51.
Yeah.
However, this is what you're going to have to be a little bit careful about. 75, so you get x is less than 5, yeah? However, x has got to be greater than 3 because x minus 3, if it's less than 3, you're going to have a negative for length, which is rubbish. So that's the thing that's the sneaky bit. So it's going to be x between 3 and 5. Okay. That's all right though, isn't it? Boom. Off you come. Next one. Rattling through these. What's going
A bit of a delay. Sorry, Morris, not for the technical difficulties.
Just normal GCSE maths? Complete the square? Shall I do it or not?
Yes, I actually learned how to do this yesterday.
So, set to a yes.
Is it a
Anybody else?
Okay, you know what? I'm a democracy.
Okay. Right. Can I just mention this about part B though? With part B, don't be daft here and like expand it out.
I was going to do that.
That would be so set too.
I did. Yeah. And then Clara.
Yours did.
I did, but Clara told me what to do.
That's so misleading.
Just take the other
I got there
side.
eventually.
Oh.
Just also.
Oh, well, you just square root it. That's so
And
easy.
square
Are
root
you
it.
thinking?
Now we get our plus or minus. So you get plus or minus root 5. And then add the 1 over the other side, so you get x is 1 plus or minus root 5.
That's it.
Well, look, one mark, so it's giving you a real clue there. Yeah. Okay? It's all good. Moving on. Okay.
Favourite topic.
Right. So, now we come back to matrices, but we're actually doing the geometric stuff. So, first thing, we've got a reflection line y equals minus x right down the matrix M. So I don't know whether you have been shown this, and I hope that I've shown you, but to do, work out what happens with y equals minus x, you look at 2 points. You look at the point 1, 0 and 0, 1, and you see what happens to them. So if you think about the point 1, 0 and the point 0, 1, that is known as the identity matrix, isn't it? So you basically look at what happens with those 2 points in reflection. So you can just think, right, if I've got the point 1, 0, there it is, there's 1, 0. If I reflect it in the line y equals minus x, which is that there, won't that go down to there? And isn't that point 0 minus 1? So that 1, 0 goes to 0 minus 1. Equally, the point 0, 1 is up there. When you reflect that, won't it go down to there, which is minus 1, 0. So 0, 1 goes to minus 1, 0. And so therefore, that is our matrix for reflection of y equals minus x. So you just look at those 2 points, 1, 0 and 0, 1, and where do they move to? And that tells you the matrix. So that's 0 minus 1, that's minus 1, 0. How are we about that?
Can I just remember that? If that comes up.
You could just memorise it, but it's a nice way for being able to work out any transformation. Because you might get transformations like rotated 90 degrees or something like that. So it's a good way of remembering any transformations. You take 2 points, you take point 1, 0, put it into a column, and then the point 0, 1, put it into a column, and you say, right, 1, 0, there it is, what happens to that? Oh, it goes over there, so that 1, 0 goes to 0 minus 1, and 0, 1 goes to minus 1, 0, figure. Okay? Right. Now then, there's a couple of ways you can do this. So, you've got a matrix. You're going to do it twice because we're doing 9n squared, and we're going to work out the single transformation that represents that. So, 2 ways you could do this. You could work out what that transformation is, and then just think, right, what happens twice? If I do it twice, one followed by the other, what actually happens to my point?
I was watching a video the other day. If you have 2 transformations and they're done in a row, is it the first one that's done first and then the second one that's done
So if you do your matrices like that,
Yeah.
B is done first and then A works inside out.
Okay.
Because you put your points, your coordinates of your point there,
Oh, and
And so
then
you do
multiply by
B.
B and then multiply by A.
get your answer, and then do A.
So it's like function.
Yes, exactly. It's exactly like functions, work inside out.
That was a set 1 answer.
Okay. So, if you have like n and then m, and it says, oh, you do m followed by n, that means you do m first and followed by n. Works out that way. Now, the alternative is, we could just work out what n squared is
That's what I did.
by doing n times n, and then saying, right, what is that in terms of a transformation? Okay? So if we do that, I'm going to go that route, I think. Yeah? So if we do n squared, we've got to do 0, 1 minus 1, 0 times 0, 1 minus 0, 1, 0. So let's do that. That times that is minus 1, isn't it? That times that, 0. That times that, 0. That times that, minus 1. So that's what n squared is. Now, if we think about it, that means our 0.10 there, there's our 0.10, it's moved to -10 over there. So if that was A, that's gone to A dash. And our 0.01 up there, point B, let's call it, has gone to 0 minus 1. So it's gone over there. B dash. So that's gone to there, that's gone to there. Isn't that rotation of 180 degrees about the origin? So it's a rotation of 180 degrees. Do you need to go?
Can I drop it?
And that is the effect of my teaching. That is
Someone just dropped the subject, guys.
perfectly encapsulates how much I motivate my students.
Bye bye! Yay! I'm so proud of you. Welcome to look, guys. Here's
Look, please this. I'm just going to cross your name out.
Yeah.
Oh.
So, okay,
Oh,
yeah.
it's all alone. This is shocking.
How many people are meant to be taking this?
Oh, there you are, right at the top of the
And where
course.
is everyone else?
38.
And
One, two,
Now,
three, four.
37.
I can't
See ya.
believe this.
Wow. Okay.
Fair enough.
So,
Wait, what's A1?
so A
It's
has
the
gone
new
to
one.
A dash, and B has gone to B dash. So can you see how
It's
that's a
just the new
rotation of
one.
180 degrees?
Wait, are you looking at the 1, 0? Is that what A is?
Yeah, so this is what would have happened to 1, 0, and this is what would happen to 0, 1. Just like over here, we consider 1, 0 and 0, 1 and what goes to it. We now know what it goes to, so we said, right, 1, 0 has gone to -1, 0, and 0, 1 has gone to 0, minus 1.
I don't understand, should we switch the numbers? Because I thought it was not. Because look, it's 0.
So that's your answer, yeah?
It's 0 minus 1 and that one's A.
Yeah,
And then
so
that one's.
my A point is 1, 0.
But is it not going to be 0 minus 1?
Yeah, because isn't that the first number? Because I thought you were comparing the first numbers from each.
Oh, no, don't forget, this is what n squared is. So I've worked out what n squared is by doing that times that, and that's now what the whole transformation is.
How do you know you have to start with 1, 0, 0, 1?
Because that's what you always start with. You look at what happens to 1, 0, what happens to 0, 1. So 1, 0 goes to -1, 0. Yep, and 0, 1 goes to 0, minus
So
1.
you no longer compare it to that.
No,
you
you're
compare it to the
not.
original.
Now you're not interested in this. You're just interested in what that gives you in terms of an answer, and then you compare it to your original and say, right, what's happened?
Oh, I didn't. Thank you. Okay.
Yeah.
What's that called? That matrices that you compare it to?
That's called the identity matrix, and it's represented by the letter I. So the identity matrix. That's the identity matrix.
So what would you write down?
Oh, so it will be a rotation of 180 degrees. Doesn't matter about clockwise or clockwise because it's 180. About the origin. I would say that's the hardest one we come across because it's just new and it's different and yeah. Okay. Can I click off?
Yeah.
Anybody else want to leave?
That was quite tempting.
Wow. Done that one. Oh, just circle them. I mean, it should be quite straightforward.
Can you go over
Notice, work out the size of the angle, we'll go over it. Work out the size of the angle OBC, and it does say you must show your workings, it doesn't say you have to give reasons.
Yeah.
If I remember rightly, you don't have to give reasons in first class.
one?
Really?
Well, that's good.
Yay!
My hand will.
Oh, good.
I will not be doing it.
Actually, I do need to learn
So
myself.
OBC is that angle there, isn't it? So So I always like to firstly label my angle, I know what it is. If that's 52, we happy that's going to be double 52?
Yeah.
Okay. So that's going to be 104.
That's where I got up to.
Okay. Equally,
BCD.
don't we know that BCD is opposite cyclic quadrilateral? So that is going to be 128.
The gap in opposite.
You're meant to watch the rugby.
Happy with that? Opposite angles to cyclic quadrilateral? So that leaves us in OBCD a quadrilateral. 108 and 128 and 104 gives us 232, and 360 take 232 gives us 128. Oh, 128 again. Is that right?
Yes.
Yeah. Now, so there's 128 between those two, and we know OBC and ODC is in the ratio 5 to 3.
Okay, bye bye.
Yeah, so we take 128 and divide it by 8, because 5 to 3 gives us 16. And we want OBC, which is the 5 bits, is 5 16ths, which is 80. Now that's possible GCSE. Be on the harder level, definitely. Can I venture that that's quite a nice question?
Yeah.
It's enjoyable.
So enjoyable.
I don't understand the alternate segment theorem. Like, I don't understand how you spot that.
Well, you literally, if you've got a tangent, all you're looking for is, does that tangent hit a chord? Doesn't have to go through the centre or anything, just does it hit a chord? That angle will be the same as any angle that chord now goes to. That's your alternate segment. So, tangent, any chord that hits that tangent, not at right angles or anything like that, off, quirky, doesn't have to be a diameter.
Yeah.
That angle you get there is the same as the chord going to any other point on the circle.
Oh, so you get the end of the chord and you...
Yeah.
Oh, okay, that's good. Thanks.
Right.
Next one.
Next one. Are we having fun yet?
Yes.
Thank you for that.
Like a quick look.
Oh, is this last year's paper?
Yeah.
Wow.
I would venture this is also GCSE.
Yeah.
So your first probable. Should we try again?
Yeah.
Your first thing to do is factorise that, because this factorise will probably involve x minus 2. Now this is where I would cheat slightly.
Cheat. No.
Well, okay, I won't cheat. What I would do is go, I'm pretty confident, unless this is a real rubbish question, that will factorise as x minus 2 times something. Because it's got to really, hasn't it? Otherwise this question is going to be really rubbish.
Yeah.
And if it's going to be x minus 2, doesn't that mean that's going to be 3x? And that's going to be plus 4, because minus 8. And then I would just kind of double check that works. So, yeah, and then I've got minus 6x and plus 4x and minus 2x. Yes, it does work. So a little bit of sensible understanding that, this question is not going to be any good unless the x minus 2 is not one of those factors. So, we've now got 21x over x minus 2, x plus 4, 3x plus 4, which we are going to turn back into that at some stage, but I'm just doing it. So doesn't that mean that we're going to have to times this top and bottom by 3x plus 4? And now we can just put them together. Care for that minus. So is it going to be on the top? 21x minus 21x minus 28. All over 3x squared minus, I'm going to turn it back into my, didn't make a mistake of course, and q minus 8. I'll just multiply that, well not I know what it multiplies, so I'll just put it back there. And so isn't it minus 28?
Yes.
Again, I think that's quite easy once you kind of realise that, yeah, it's got to be an x minus 2 as a factor. And then assuming it and getting that, then just quickly double checking that yes, it does work. Or wiggle it right.
I was just about to say, I like the wiggle method.
Yeah, it's fine.
Wiggle method.
It's the best method ever.
Different way.
All the time. It's not like this trial and error rubbish. It's 100% gonna work every time.
Just got to ask yourself the question: how many maths teachers use the wiggle method?
Mr. Holmes said it was stupid.
Mr. Holmes, as usual, is right.
As usual.
I'm not sure about that one.
Again, a very hard GCSE cert.
Yeah, that was in our test, but like easier.
Two thirds in GCSE, like with 2 thirds on the bottom. Because I don't know if it's.
I've never seen it, but was it on the thing?
No, there was one. It was like
It's
1/3 one number.
Oh, it's a good
Yeah,
question.
yeah.
It's a new point.
And it was
now,
like
it's not what it came up
Question
with,
16 or something, so it was really near the end of the paper, but it was
I can't
kind
see
of
a reason
okay.
why not. So are we happy with times by root 5 plus
Yeah.
root 3?
Yeah.
Can I leave this?
Yeah.
Wait, what was the answer?
9 plus 2 root 15.
Yeah.
I think.
Yes.
Okay. So we just times up just for the YouTubers out there.
Norse nuts, that's you guys.
You times by that and away we go. Right. What are we on next?
90.
Yeah. And that is.
Stationary points.
Oh, did you write down the topics that Maisha said to write down?
No, I've got mine from the last book.
Okay, well tell me all.
It's gonna be on YouTube, it's fine.
There's 2 stationary points, it looks like. Good. So this will not be on the GCSE, of course, it won't. No, I'm on the
Wait,
wrong
how
place.
soon can you get this edited though?
Okay.
I'm not allowed it.
So stationary points are
My
where
favourite.
I don't know what stationary point is.
stationary point is something like this.
It's where
All these 3, that's called a point of inflection. But all these 3 have one thing in common. At the bottom, if I did a tangent, or even this point here, it would be a flat tangent, i.e. the gradient would be 0. So all stationary points, you are looking for the gradient, which in further maths, we're thinking about dy by dx being 0. So what we need to do is firstly, do dy by dx and make it equal to 0. So this one's not a bad one. So you get dy by dx equals 3x squared minus 6x.
Yeah.
Oh, that's it.
Yay.
Lovely. The 5 obviously when you differentiate comes out 0. That's got to equal 0. Don't overcomplicate things, just take 3x out. Obviously as a factor, not dividing by 3x, because then you're going to lose one of your values. So doesn't x equal 2 or 0? Or 0. There you go. Happy with that? Right, they want the coordinates, so at this point should we just quickly work out the y?
Yeah.
So when x equals 0, y equals 5. That's an easy one. And when x equals 2, y equals something else.
1.
8 minus... Yeah.
You sound surprised.
Interesting.
Yeah?
Yeah.
Okay. Right. Now then, we need to work out the nature of these. And this is where it becomes a little bit more tricky. So, this one's going to be the easy one, that's going to be the nasty one. There's a couple of ways in which you can do this. The first and nicest way is looking at what we call the second derivative, which is when we differentiate again. And for what's known as a minimum point, the second derivative will always be greater than 0. And this is, you just have to learn this. Here, for a maximum point, the second derivative is less than 0. Here, second derivative is going to be 0. But, and this is the problem, if it's actually equal to 0, it doesn't necessarily mean that it's in point of inflection. It actually can be either of these. So let me just clarify that. If you do second derivative and you've got greater than 0, it's definitely a minimum. Or less than 0, definitely a maximum. If you get it actually equal to 0, it could be any of these three. So this is not like all minimums have greater than 0. It's just if you've got greater than 0, it's definitely a minimum. Now, second derivative. So let's work out the second derivative. So we differentiate again. And we get, annoyingly, oh no! Silly me. It's going to be okay. We get dy by dx equals 6. Second derivative equals 6x. No.
6x minus 6.
Second derivative is 6x minus 6. So, when we put x as naught in, are we happy that the second derivative is going to be minus 6?
Yes.
And because it's minus 6, that means that point, 0, 5, negative, is a minimum. A maximum, sorry. Doing so well here. And then when we put x equals 2 in, we get the second derivative being 6.
Yeah.
And so therefore, it's
Minimum.
max.
Minimum.
Minimum.
This is so.
Now,
I've never been to do that.
The alternative, just in case you get one that's equal to 0. If you get one that's equal to 0, then instead, just come back to your dy by dx. And you put in a value of x for your dy by dx just before your turning point, your stationary point, and just after. Now the reason why you would do that, can I do it with one of the points we've got here? So let's take the x equals 2. So if I put x equals 1.9 in, and I put x as 2.1 in, if I work out what dy by dx is when I put y 1.9 in, yeah, I put that all in, and can I just tell you what I would get? I would get a number, and it would be, because I can't do 1.9 squared times 3 minus 6 times 1.9 without having some kind of mental breakdown. You would get, what's the 2, 1? 2 is positive.
It would be
So
smaller,
it's-
right?
Yeah, it's going to be a negative. So you're going to get a negative number when you put 1.9 in. When you put 2.1 in, you're going to get a positive number. Okay, this is just putting actual 2.1 in there. Okay. Obviously, yeah, anyway. And obviously when it's equal to 2, we know it's equal to 0 then, because we've already worked out that when x is 2, dy by dx is 0. Right, that means it's a negative slope to start with, then it goes to 0, then it goes to a positive slope. And that,
Minimum.
minimum, is a minimum. So if you look just before and just after, yeah? Now that's more likely to happen on a calculator paper. Because doing 1.9 and everything, not on a non-calculator. So I think if you're going to get it on non-calculator, you're going to get nice numbers where you can easily go, oh, yes, that's a minimum, that's a maximum. Yeah, maximum, minimum.
If it's 0 just before and just after, then is it a point of inflection?
So if it's a point of inflection, what would happen for this particular point of inflection, you would get a positive just after, just before, and a positive just after.
Okay.
You get the same. Okay. That's quite tricky, that.
Yeah. Wait, so what even is the answer?
Right, okay. Do you want me to write it on? So, have I remembered?
I've got it
Can I
written
just
down.
say? So your stationary point, what's your first stationary point?
0.5.
0.5.
0.5, and that was a
Maximum.
maximum. So you write 0.5 maximum.
Oh, so there's the d squared y, like with the other thing?
Yeah.
Just tell me what is maximum
nature?
minimum. Yeah, the nature,
Oh,
yeah.
I see.
Yeah. And then the other one was 2,
2,
1,
1.
2, 1 minimum.
Yeah.
Okay. Keep going.
Got a graph on and then for the next,
What
it's
we
on
got
the
to do
next
for it?
page.
Draw a line.
Is this the
It's
last
approximate
question?
No,
solution. No,
there's 23 questions.
Okay.
This is 20.
alright.
23 out? Oh, yeah.
So, remember that x squared minus 7 over 2x minus 3. You remember it.
Yeah,
Sure.
you've got it then.
I'll just go with that.
What's it again?
X squared minus 7 over 2x minus 3.
Ah.
X
X
squared.
squared.
The best
X
thing
squared.
ever.
You might want to make it minus though, eventually.
Yeah.
Yeah.
So
X squared minus 7 over 2x minus 3 equals 0.
Okay. Now, with all these kind of things, and again, this is GCSE, but a lot harder. It's still a GCSE topic. What you're trying to, I suppose this is simultaneous equations using graphs.
Thank you.
Would be possibly the best description of what's happening here. So, you've got that graph. You need to have that graph in your equation. At the moment, we haven't got that graph in the equation. We've got nothing like that graph, but we can engineer it. So, first of all, I'm probably going to take that x squared over the other side. So now, I've got my minus x squared bit on this side. Yeah? I now need 3x on this side. So why don't I just add 3x to both sides? Now if I add 3x to that, won't they give me a half x? Because minus, no it won't, won't it give me minus half x? Oh my
He's
god.
doing great today.
I'm having such a bad day. Minus x squared, what am I adding?
Minus
3x.
x, not squared.
Yeah, it's squared.
Oh,
Is
sorry,
that right?
I thought you said half x squared. Yes.
So minus half x minus 3.
Yeah.
So I've got minus x squared plus 3x, so I've got my plus 3x. Now I need 6. So why don't I just add 6 to both sides? So won't that become minus a half x plus 3 equals minus x squared plus 3x plus 6. And now I've got the full curve on this side. So now that's the curve that they've drawn for me. This is the line that I'm going to have to draw. Y equals minus half x plus 3. So I'm going to have to draw the line y equals minus a half x plus 3 on my graph. And I do a couple of quick easy points. Y intersects 3, so bang, there. Let's pick another easy point. Let's pick x is 4. When x is 4, won't y be minus 1, sorry. Yeah. Don't listen to her. There. Do you want to pick another point just in case? How about when x is minus 2? Won't y be 4? And then straight line through, read off your values to there.
Whichever order I can put it. Thank you.
I think we're just going to do paper 1, aren't we, today?
Yeah.
What are we trying to do?
Okay.
2.
I thought we were going to do the whole course.
Sorry,
It's okay, brilliant. I'll come next time.
maybe.
It's the
Just
one.
to tell me your question.
Or I'll walk out like you do, but either or.
That was quite spectacular. Are we all happy with that? So my very, 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 very rough one, because I didn't have a ruler, is about minus 0.6 and 4.1-ish, 2-ish.
How about the intercept?
Yeah.
What did you get for?
I don't know.
If I didn't have to do
Oh, I got
Well, no,
minus
4.3 perhaps.
Okay, I didn't
Something
know.
like that.
4.2.
Anyway, mine's not a straight line, so mine will be wrong. We're all happy with that?
Yeah. So how would you give the answer? Just the 2 points?
Just the x value,
Okay.
not the coordinates, because the question here is work out possible solutions to that equation. And that equation is just x equals. So you just want the x values, you don't want the coordinates.
Oh, so
You
just
want
two
the x coordinate of where that line and that quadratic met.
If I didn't know how to do it and then I just drew like a random line and then like did the point, would I get marks for that?
You
Because
might
that's
get
like
a mark, but probably not.
my graph.
Maybe not.
I don't know.
You might get like 1 mark for demonstrating skill that you have to read off a
What,
graph.
using a ruler?
But no, like reading off a graph or something. But I doubt you'd get like.
I'd only have
Like
4
maybe
marks, so
four.
that would be quite a lot of marks. For that.
Yeah.
Ooh,
Ooh, this is quite
this
fun.
is one. Yeah, it does look fun, doesn't it?
Yeah.
I take it we'd all turn that 8 into 2 to the power 3.
Yes, you would.
So you're going to get the same base. You're going to get a quadratic here.
Oh, so then can I just get rid of the 2?
Not rid of the 2. No. Sorry. No. But when we raise the power, don't we multiply the indices? So over this side, won't it be 2 to the power of x plus 3 times 4x plus 1? And over this side, won't it be 2 to the power of 3 times x minus 1? Now you can get rid of the 2's if you like.
Oh yeah, I was already at that one.
Sorry, I'm slower than you.
Yeah.
So you get 4x squared
Oh, can I do the wiggle
plus
method?
1.
This is the wiggle method.
13x plus 3 equals 3x minus 3. All on one side, so you get 4x squared plus 10x plus 6 equals 0. I personally would divide by 2 there, because everything can divide by 2. And that will give me a slightly easier quadratic to factorise. Then, being a maths teacher, not a set-tour, I would.
Oh, I've already done it though, I've already factorised them.
You are so good. Plus 3 and plus 1 there. So that means that x is minus 1 or minus 3 over 2.
Wait, what? Let me just look at mine then.
Is that wrong?
No, it's right. I think. I got it.
Wait, what 2 brackets did you have?
2x plus 3, x plus 1.
Oh yeah, I got that too.
Wiggle method.
Oh, no, I did not. Just hang on for a minute. 2,
How's that though?
4,
Good.
Makes sense.
x,
Yeah?
x plus 4. What's wrong with mine then? Wait.
Where do I start?
So I got, sorry, that's 4.
What even is the wiggle method?
Who knows?
So,
Unimportant.
uh, 4x squared plus 10x. You've got 4 there. Oh, you failed to do 3 times minus 1 minus 3.
Oh, that's so annoying!
Yeah.
I didn't even do the wiggle method wrong. But, oh, that's just...
Every time I have a calculator paper, I always trip up on like. You know,
The
minus 4
easiest.
times minus 4. Stuff I
Yeah.
don't think to put in my calculator.
No, I didn't mess it up, because...
At the top, 3x
Yeah.
minus 1 is 3x, not 3x minus 1, it's 3x minus 3. Sorry, that sounds a little bit
Just a little bit.
aggressively. Whereas, actually, I'm a nice teacher, really.
Wait, so what achievement is it? I don't... You know what, I'll do that.
Let's trigger entities next.
Yes! I'm good at these.
Yeah, I got
I'm
really
really bad
confused
at
on this
these.
I didn't
question.
really answer, but I got that. I think that could be right.
Tan definitely comes into it, yeah. Okay, so this one. Simplify f of x and hence solve that. The first thing I notice, so the trick identities that you will be working with is sine squared plus cos squared equals 1. So sine squared x plus cos squared x equals 1 is a go-to. And then also sine x over cos x
Equals sine x.
equals tan x, yeah. Those are your 2 main ones you're working with. Now, you see the sine squared and the cos squared, it's very tempting to turn those using that into 1 minus, etc. I'm not going to do that, because instead I can see on the top, can't I factorise sine x out? And on the bottom, can't I factorise cos x out?
Yes, you can.
I'm glad of that. I can also take a 4 out on the bottom, can't I? So don't I get that f of x is sine x out? Don't I get 3 cos x plus sine x? 4 cos x out. Aren't I left with 3 cos x plus sine x? Oh, there's some cancelling.
Oh, I didn't take the 4 out. Is that an issue?
Well, you'd have to spot then that this is actually just a multiple of that.
I did, but then.
Oh, well done. That's all right then.
But I didn't think it was right. Because I got a quarter cos x, so when I was in
Yeah, well. So, isn't that tan x a quarter tan x? Because you've got 1 over 4, and then sine x over cos x is tan x. So isn't that quarter tan x? And that apparently is minus root 3 over 4. It's a non-calculator paper, so this must be involved in some nice trig values. So, times by 4 both sides, don't we get tan x equals minus root 3? And now, it depends on what you've been taught. So, firstly, if I had said tan x equals root 3, do you know what angle we're talking about there?
60.
60 degrees equals indeed. So tan of 60 is root 3. However, it's minus root 3. So, cast diagram.
I'm really good at these.
You've done cast diagram?
Yes.
Excellent.
All Scousers taught crap. I know.
Okay.
That's how I've been taught in my.
So, I have quite a following on my YouTube channel from Liverpool. So,
Apologies.
Yeah.
I love the Scousers.
Okay. Right, so we've got tan being a negative number. Doesn't that appear there and there?
Yes.
And we know root 3 is a 60-degree angle, so it's 60 degrees there. Okay? Now then, we want between 90 and 180. I don't know what 90 is, I don't think it's a cool number. But 90 there, 180 there. So we want this one in there. Isn't that
120.
120 degrees?
Yes.
So x equals 120.
I think I would have gotten about like 1 mark on that box.
Yeah.
Is that virtual last question?
Second
There's
class.
one more.
One more. Oh, I'll quickly do that. Is that okay?
Do you have a lesson then this period, next period?
It's my PPA, so I'm actually going home. But
Oh wait, I didn't get the answer.
I will finish this last question for you,
Thank
as long as there's no group in here next lesson.
We'll kick them out. We're the priority here.
I think unless they're
Unless
sixth
it's
form, then
Yeah, unless they're junior six,
yeah,
you mean it.
then I think we could just kick them out. The assessment don't matter.
Right, the first focus is this sequence of that, work out the values of x and y. It's quite easy, this.
Yeah.
So, isn't that the wrong thing to do? Isn't that when n equals 1?
Yeah.
So that's when n equals 1, that's n equals 2, that's n equals 3, and that's n equals 4. So when n equals 1 in there, doesn't that give us a minus 5 plus c? And we know that's got to equal 2. And put n equals 3 in here, and doesn't that give us 9a minus 15 plus c? And that happens to equal 16 apparently. So can't we therefore work out what a and c is? Just by subtracting, so you get AA
Is this a triple simultaneous?
minus
No,
10
just double simultaneous. There are only
equals 14.
Oh yeah.
and then
So A is 3, And if A is 3, stick it in there. C is 4.
Yeah.
And now we know our A and our C. That means it's 3n squared minus 5n plus 4, because that's what our A and our C is. So x is when n is 2, so stick 2 in there. You get x equals 3 times 2 squared minus 5 times 2 plus 4. So that's 6.
Yeah.
And stick 4 in there to get what y is.
32.
33, thank you.
32. 2.
32.
Yeah.
Definitely 32. Right.
Wow.
Exactly.
What a session.
Well, that was fun.
Right. Very quickly then.
Should I stop filming?
Yes.
Bye guys.
Thank you so much for watching.